Hey everybody, just want to walk you through some Ohm's Law practice problems and so you have a better understanding how to do some of the stuff. We're on the electricity unit, and Ohm's Law basically just ties the idea of current, voltage, and resistance all together. One of the things we're going to use a lot over here is the triangle. V stands for voltage, I stands for current, R stands for resistance. So if we're solving problems with this, what we're going to do is we're going to first write down our given. So if we're going to do number one, we're going to write down our given. So we're starting off with resistance is equal to 1,000 ohms, and our voltage is equal to 1.5 volts. And we're going to go ahead and plug in, we're looking for current. Okay, so if we use our triangle, it's kind of crappy here, sorry. Okay, what we're looking for in this case is going to be I, so we cover by, and we get V divided by R is going to equal what we're looking for. So V divided by R is going to equal I. Okay, so in that situation, what we're going to do is we're going to go ahead and plug in 1,000. I'm sorry. Let's plug in the right numbers. We're going to get 1.5 volts divided by 1,000 ohms of resistance. Okay, now if I plug that into the calculator, I'm going to get let's go ahead and turn that on clear. So I'm going to take 1.5 divided by 1,000 equals, I get 1.5 times 10 to the minus 3, 1.5 times 10 to the minus 3, and that's going to be measured in amps because this is current. Or if I want to rewrite that, I can put 0.0015 amps. Both of those are correct. Okay. All right, let's go ahead and do number 2. Okay. Number 2 says, in the filament, the resistance of the automobile headlamp is 3 ohms. How many amps does it draw when connected to a 12-volt battery? So let's write down our givens. Resistance is equal to 3 ohms. Voltage is equal to 12 volts. Okay, we're still looking for current here. So V divided by R is going to give us our current. So that's going to be 12 volts divided by 3 ohms. We end up getting 4 amps. Okay, fairly straightforward. Slide down here to number 3. Let me slide up to number 3. Number 3 says the resistance of side lights is 10 ohms. Voltage is 12 volts. So again, we use the same formula. So we're going to get 12 volts divided by 10 ohms. So we're going to get 1.2 amps. Okay. All right. Going to do number 4. See if I can make this piece of paper work. All right. In this case, we have a current. It's number 4. Sorry. Current is equal to. Oh, it says what is the current? So that's what we're looking for. We know resistance is 30 ohms, and voltage is equal to 120 volts. Okay. So again, I is going to equal V divided by R. Put this in 120 volts divided by 30 ohms is equal to 4 amps. Okay. Moving right along. Stop this up a little bit. All right. Get another new piece of paper here for number 5 because number 5 is a little tricky. Okay. Number 5, fairly straightforward, but first of all, our voltage, it says during a lie detector test, a voltage of 6 volts is impressed across 2 fingers. When a certain question is asked, the resistance between 2 fingers drops from 400,000 ohms to 200,000 ohms. What is the current initially through the fingers when the resistance between them drops? So there's 2 parts here. So we're going to start off with our 6 volts. Okay, resistance 1 is going to be 400 ohms. Resistance 2 is going to be 200. Not 2, excuse me. Sorry about that. All right. So same basic idea. We're still working for current. So I is equal to V divided by R. Okay. So we'll go ahead and plug these in. We end up getting, for the first part, part A, it's going to be 6 volts divided by 400,000 ohms. And when we do that, we end up getting 1.5 times 10 to the minus 5 amps. Okay, now the setup is exactly the same for part B. All we do is change the resistance. There's 200,000 ohms. We plug that number in, we get 3.0 times 10 to the minus 5 amps. Scientific notation just makes this a little bit easier, so I don't have to work with quite as many zeros. Okay? All right. Let's take a look at number 6. I may be going a little fast here, but if I make it too long, the videos are too long, they take too long to upload. Sorry about that. Number 6, basically we are given, says how much resistance allows an impressed voltage of 6 to produce a current of 0.006 amps. Okay, so first of all, let's write down our givens. We know voltage is equal to 6 volts, and we know current is equal to 0.006 amps. Therefore, we're looking for resistance. Okay. Okay, so when we go look for resistance, go ahead and use our equation. There's volts, there's current, there's resistance. So if I'm looking for resistance, I cover up R. So V divided by I. So 6 volts divided by 0.006 amps is going to equal 1,000 ohms. Okay. All right. Everybody get with me so far? Good. Let's take a look at. Go first. Get your paper here. 1 sec. Sorry for the confusion. All right. Let's take a look at number 7. Number 7 says, what is the resistance of a closed iron and it draws a current of 12 volts or 12 amps at 120 volts. So voltage is equal to 120 volts. Current is equal to 12 amps. Okay, so resistance is equal to question mark. Okay, so again, we use the same basic idea. Voltage is equal to current times resistance. Okay, so in this case, I'm looking for resistance. So V divided by I is going to give me my resistance. So resistance is equal to 120 volts divided by 12 amps, and I get 10 ohms. All right. All right, let's take a look at number 8. And I know this is starting to get a little crazy, but we're almost done. All right, number 8. What is the voltage across 100 ohm resistance? So then we have resistance is equal to 100 ohms. Current is equal to 1. Okay, in this case, we're going to use our triangle again. V is equal to IR. So in this case, since we're trying to find voltage, we cover up the V, so it's I times R. Sorry about the phone ring. It's just Walgreens calling me. So resistance is equal to 100 ohms times 1 amp. So what's 1 times 100? Okay. So in this case, our current is going to equal, or I'm sorry, phone got me all confused. All right. Voltage is going to equal voltage times, or resistance times current is going to be 100 times 1. So the volts then is going to be 100 volts. Sorry for the confusion. The phone got me on my game. All right. Number 9 says, what is the voltage produced when 3 amps through a 15 ohm resistor? Okay, so I've got 3 amps. So I is equal to 3 amps. Resistance is equal to 15 ohms. Okay, V is equal to IR, which we just established. All right, so V is equal to 3 amps times 15 ohms. So 3 times 15, voltage is going to be 45 volts. All right, last one. And then a bigger piece of paper for this one. All right. This is the current in an incandescent lamp is 0.5. So I is equal to 0.5 amps. Okay, when it's connected to a voltage of 120 volts. So the first thing we're going to do is solve for the resistance of the first part here. So if we do that, we're going to go ahead and get 120, resistance is equal to voltage divided by current. So my voltage could be 120 volts divided by 0.5 amps. And we end up getting an answer. Resistance is going to be 240 ohms. So that's the resistance going through that particular circuit. Okay, now when we take this and hook it up to a different voltage source, okay, it says the current incandescent lamp is 0.5 amps, so connect to 100 volts. And then when connected to a 10 volt source, so in other words, what we've done is you unplug the lamp and plug it into a different voltage source. So we plugged it into a voltage source that's only 10 volts. Our current then drops to 0.2 amps. So now what's our resistance? So one thing you might know is if you change the voltage on a light bulb, what ends up happening is it's not nearly as bright. So that's what we're looking at here. The resistance is going to determine how bright this is going to glow. So let's go ahead and plug those numbers in. Resistance is equal to V divided by I. So that's going to be 10 volts divided by 0.2 amps. All right, clear. So 10 divided by 0.2 equals, resistance is equal to 50. Okay, so the resistance is a lot less here, which means this light will be a lot less bright. All right, hopefully this helps a little bit. Make sure you review this video before you go ahead and start trying to do the practice. It will make a huge difference. Thanks, and I'll talk to you soon. Have a great day.